Hello, so in this video we will talk about some applications of binomial theorem. So specifically we will talk about how to simplify a sum. Okay, so let's take an example here. So let's say uh, we have a sum like this. We have nc0 plus 2 times nc1 plus 4 times nc2 plus up to 2 to the n times ncn. Okay, so if I write it in a summation form, what should I say? I say k is equal to 0 to n nck 2 to the k, right? Now this 2 to the k I can also easily write times 1 to the n minus k. Why can I do it? Because 1 to the power of anything is just 1, and I'm multiplying this 1 by each of these terms, which will keep the sum unchanged. So then this is, if I compare it with this one, if I compare it with this guy, what do we get? We can say it that this is my a and this is my b. So this is equal to 2 plus 1 to the power of n, which is equal to 3 to the power of n. So this is a simplification of this sum. Okay, so this is actually equal to 3 to the power of n here. Okay, now let's do one more example. Let's say if we have this situation, nc0 minus half nc1 plus 1 over 2 squared nc2 minus 1 over 2 cubed nc3, and then plus minus up to plus minus 1 to the n minus 1, 1 over 2 to the n minus 1, n c n minus 1. Okay, now let's write it in a summation form. So I have k is equal to 0 to n minus 1, because the last one is here n minus 1. Okay, so then this guy I can say n c k, and then I have minus half to the k, and then I can again introduce 1 to the n minus k. Okay, without changing the summation. So then this would be equated to a binomial sum if I had n here, but I do not have n here. So what do? First of all, I will add the nth term, and I will say n here, and k minus 1 to the minus half to the k, 1 to the n minus k, and then I'll subtract this nth term. So we'll say minus n minus half to the n, and then 1 to the 0, which is just 1. So I don't need this term. So I can say, now this guy is the binomial sum, and I can say it that this is my a and this is my b. So I can say half to the n, correct? Because minus half plus 1 is half. And then this guy is, this ncn is just 1, and then I can say minus half to the n. Okay, now this sum is if n is even, then minus half to the n is just half to the n, correct? Because this I can say it as minus 1 to the n times half to the n. So now if n is even, this guy is 1, and then I am left with this one. So then this means that if I say it equation 1, so equation 1 means that this is half to the n minus half to the n, which is equal to 0. Okay, but if n is odd, I will have minus half to the n, this is equal to minus half to the n. because this guy will give me a -1 here. Okay, so then 1 becomes half to the n plus half to the n, which is equal to 2 times half to the n, which is equal to 1 over 2n minus 1. So this means if I go back here, that this sum is 0 when n is even, and this sum is equal to 1 over 2n minus 1 if n is odd. Okay. So this is another application of how to simplify a sum using binomial theorem. Okay, so our last example, if we have this guy, k is equal to 0 to n ck x to the k, then again I can introduce 1 n minus k, so this becomes 1 plus x to the n. Okay, now if I differentiate, for example, differentiate with respect to x both sides, so the left side becomes k is equal to 0 to n remains the same, and ck remains the same, and I am left with k x k minus 1, correct? And on the right side I have n 1 plus x n minus 1, correct? So in other words, I can bring this n on this side, this n I can say divided by n, and I can say divided by n, and I am left with 1 plus x to the n minus 1 is equal to this sum. Okay, so now what is the application of this? So the application of this is, for example, I have x is equal to 1, then I have 1 over n k, summation is equal to k to 0 to n k n k. So this is equal to, put x equal to 1 here, so 2 to the n minus 1. Okay, and without loss of generality, you can change this summation to start from 1, because 0 will, k is equal to 0 will make this term 0, right? And if I put x is equal to -1, I can say 1 over n k is equal to 0 to n k n k minus 1 to the k, this is equal to 1 plus -1 to the n minus 1, which is equal to 0. Okay, so the point here is, all we have to do is we have to observe that a sum, so what is the summary? So observe if a summation can be written in terms of binomial sum. And what is the next step? Next step is just simplify. Okay, and hint, what is the hint? Hint is use 1 to the power of anything to uh, uh, to make the sum look like binomial sum. Short set of examples in which we have done